and welcome to Lesson 8C. I can use trigonometric ratios both with and without a calculator to find missing values in a triangle. So trigonometry is a branch of mathematics that really studies the relationship of triangles, and it's all based on relationships within right triangles. In particular, it's going to focus on sides and angles. Up to this point, we've been considering them completely separately, sides or angles. Now we're going to start putting those two concepts together. The foundation of trig are three functions: sine, cosine, and tangent. And in order to understand sine, cosine, and tangent, we have to have some really specific vocabulary when we talk about the location of sides and angles. So we've got a diagram here, and guys, for some reason, the printing in your books maybe didn't come out the way I wanted, so you may have to correct some things in your book as we go along. But if I'm looking at angle C has an adjacent side of X and an opposite side of Y, and Z is the hypotenuse no matter which angle I'm talking about. If I'm looking at angle B is adjacent to side Y, that means it's actually physically touching side Y, and opposite side X. So it's very important, guys, that you know the difference between the adjacent side and the opposite side and the hypotenuse. The hypotenuse is never the adjacent side. So just know that. Or consider. Is never considered. Because it is clearly adjacent, but it's not ever going to be the adjacent in our building blocks. So we have, again, three fundamental building blocks, and they are the functions sine, cosine, and tangent. And sine is defined as the ratio of angle B is the ratio of the opposite side over the hypotenuse. So when I look now at angle B, here's my angle B, my opposite side is X, and the hypotenuse is Z. So for angle B, sine is X over Z. Cosine of angle B is defined as the adjacent side over the hypotenuse. Well, my adjacent side again for angle B is X. My hypotenuse, not X, my adjacent side is Y. My hypotenuse is still Z. So adjacent over hypotenuse for angle B is Y over Z. For tangent of B, tangent is defined as the opposite side over the adjacent side. And opposite over adjacent for angle B is X over Y. Guys, be sure to write these down right in your guide, because this is the big idea. This is the big deal for today, okay? This is the big idea. All right, let's look at angle C. Angle C is really similar. We have the same ratios, so sine is still opposite over hypotenuse, but opposite of angle C is side Y. That's my opposite side, all right? And then the hypotenuse is always Z no matter what we're doing. Well, cosine of C is adjacent over hypotenuse. Well, my adjacent side for C is X, and my hypotenuse is Z. And tangent of C is opposite over adjacent. Well, we discovered that opposite of C is Y, and adjacent is X. So guys, really, the way you're going to remember these values is through one really easy relationship, and that is SOHCAHTOA, okay? If you know SOHCAHTOA, you know 98% of trig that you're going to learn this year. What SOHCAHTOA stands for is sine equals opposite divided by hypotenuse, cosine equals adjacent divided by hypotenuse, and tangent equals opposite divided by adjacent. That's what SOHCAHTOA stands for. So it's not too bad. It's a really quick, easy relationship. So let's now take a look at how we would do this. Now, I recognize some of you guys, you might be missing this diagram. You're going to want to draw him back in. I'm sorry you're missing the diagram. I don't know what happened in the printing. All right, let's take a look at this. So when I'm identifying my hypotenuse is DF, okay? And the side opposite angle F is DE. My side adjacent to angle F, well, here's angle F. Adjacent to angle F would be FE. And now let's look at angle D. My side opposite of angle D, so here's angle D, opposite of angle D is FE. And the side adjacent to angle D is DE. Notice if we're adjacent to angle D, the D is actually included in the adjacent side. So now let's look at my ratios. Sine of D, well, sine is opposite over hypotenuse. Well, opposite of angle D was FE, and my hypotenuse is always, that's an E, I promise, DF. Okay? Cosine of D is always SOCA, AH, adjacent over hypotenuse. So my adjacent over hypotenuse, the adjacent side to angle D is DE, and my hypotenuse is still DF. And then for tangent, tangent equals opposite over adjacent. Well, opposite of DE is FE, or opposite of angle D is FE, and the adjacent is DE. Okay, now we're going to repeat all of this now, but for sine. And I'm going to switch colors, or for sine of F, angle F. So now I'm looking at angle F. Sine is always opposite over hypotenuse. Well, opposite of angle F is DE. And then hypotenuse is still DF. Notice that hypotenuse is not changing, even though I changed angles. Cosine is always adjacent over hypotenuse, AH, right? Well, my adjacent to angle F is FE, and my hypotenuse is still DF. And then tangent of angle F is always opposite over adjacent. Well, my opposite of angle F is DE, and the adjacent side to angle F is FE. So that's all we do. That's how we use the ratios. So now let's actually throw some numbers in there. We're still looking at SOHCAHTOA. SOHCAHTOA. And I'm going to take a look. Sine of B, well, here's angle B. That means that this side is my opposite side, this side's my adjacent side, this side's my hypotenuse when I'm looking at angle B, okay? Well, angle B, sine is opposite over hypotenuse, that's O over H, or 40 over 50 in this case, which is just 4/5. Cosine of B is A over H, adjacent over hypotenuse, right? Well, my adjacent side here is 30, and my hypotenuse is 50, so that reduces to 3/5. And tangent is opposite over adjacent, right? Here we are, tangent opposite over adjacent. Well, my opposite side is 40, my adjacent side is 30, which means that my answer here is 4/3. That's my ratio. Now let's see how all this changes when I look at angle C. Well, here's angle C. And my opposite angle C is 30, so that's my opposite side. My adjacent side is 40, and my hypotenuse never changes, right? Hypotenuse never changes. So sine is O over H, right? So opposite here is 30, H remains 50, and so I get 3/5. Cosine is adjacent over hypotenuse. Well, adjacent over hypotenuse now is 40 divided by 50, which equals 4/5. And tangent is opposite over adjacent, O over A, and that's 30 over 40, which is 3/4. So now, why don't we calculate sine of angle A? Well, if you notice, angle A is my right angle. Angle A is a right angle. And at this moment, the opposite side is the same side as the hypotenuse. So it wouldn't make any sense. So that's why we don't do it. All right, let's take a look at how to do this with a calculator. So now that you know how this is going on, we're all going to now set up our calculators together. So I want everybody jump into your calculator for me real quick. And before we do anything, we need to all put our calculators in the right mode. Right now, you guys are only going to work in one specific type of angle, and that's degrees. That's the angles you've always been working for. So I really want you now all to go to number 5, settings, number 2, document settings. And this right here where it says angle, right now it says radian. Y'all don't know what that is yet, so we're going to change it to degree. And we're going to make that our default. Okay, when you get to pre-cal, you can change that, but right now we're going to make that the default. So let's take a look real quick and see how we're going to use the calculator to help us. I want to calculate the sine of 30 degrees. So when I go into my calculator, we actually have this button right here. It says Trig. If I click the Trig button, I've got all of these options. Whoa, I don't know what my computer's doing, guys. Don't know what's going on. Not a clue. Let's pause. Okay, trying this again. We have a button that says Trig. When I click it, I've got my options. Y'all are just going to deal with these 3 buttons in this class, sine, cosine, and tangent. So I'm going to click the sine button, and I'm going to type in 30. We're already set in degrees, so I just hit 30, and I notice that 30 equals 0.5. So coming back here, sine of 30 degrees is 0.5. Now let's look at cosine of 30 degrees. So I go to my Trig button, cosine, not again, 30 degrees, and we get super funky number, 8.66. So I'm going to come back over here. We're rounding to the nearest tenth, so that gets me 0.9, so on and so forth. I want you guys now to pause and fill out the rest of this table on your own. All right, so we actually have some pretty cool relationships in here too. If we look at this, do y'all see here the sine and cosine, that we have some pairing going on here? Well, when you've got 2 numbers that add up for angle values that add up to 90, the sine of one will equal the cosine of the other and vice versa. So there's some neat relationships in here. And the tangent is actually, in the end, because tangent equals O over A, well, sine equals O over H, and cosine equals A over H. Well, if I do sine divided by cosine, that gets me O over H over A over H, which is O over H times H over A. Those cancel. We get O over A. So we can say, therefore, by the way, guys, 3 dots means therefore. Therefore, tangent is actually equal to sine over cosine. So that's kind of a cool thing. Let's do a couple of examples. This is going to end up being a 2-lesson video. So let's take a look at this first example here. Whenever we do a problem, we're always going to start off by identifying the angle measure we're worried about. In that case is F. So the first thing is we identify an angle. Then we're going to label our sides. Okay? Well, across from angle F, my opposite side is the X. The hypotenuse is here, and my adjacent side is the 13. Then we're going to choose a ratio based on what we have. So here, I am hunting for the X, and I have the 13. That's an O and an A. So when I look at SOHCAHTOA, the branch that has an O and A is tangent. So I'm going to use tangent of theta equals O over A. And y'all are going to get to see me finish the problem in the next video, so be sure to watch the next video.